What if I told you that Voyager 1, drifting 25 billion kilometers from Earth, just revealed its most shocking secret? NASA's quantum AI has decoded a terrifying message hidden in prime number patterns since 1977. Michio Kaku calls it a whisper of non-human intelligence, geometric fractals forming humanoid silhouettes in deep space static. This isn't science fiction. It's our reality being rewritten by mathematics itself. The universe has been speaking to us all along and, well, we're finally learning to listen. Voyager's impossible signal. Hold on to your seats. What Voyager whispered through static for decades just got a voice. After nearly half a century of drifting beyond Pluto's orbit, Voyager's faint cryptic beeps were dismissed as cosmic background noise, until NASA's new quantum AI peeled back the layers of interference and revealed a breathtaking secret. Hidden within those ancient transmissions was not random data, but a perfectly coherent image, an architectural marvel of concentric rings and fractal spires, like an otherworldly cathedral carved in starlight. This wasn't mere chance interference. The AI unearthed deliberate patterns, suggesting a civilization with mastery over mathematics and electromagnetic resonance. Every pixel aligned with prime number sequences, painting a portrait of precision far beyond human engineering. The revelation forces us to rethink Voyager's legacy, from a lone messenger sailing into the void to an unwitting carrier of alien artistry. What purpose did this cosmic gallery serve? Was it an invitation, a warning, or simply an archivist's pride? As quantum bits unraveled centuries-old code in hours, the line between signal and story blurred. Suddenly, those distant echoes transformed from scientific curiosity into a dialogue across the stars, challenging our assumptions about life, intelligence, and the very fabric of reality. Now, standing on the cusp of AI-driven discovery, we confront a profound question. Are we listening to a message meant for machines far more advanced than ourselves? If Voyager's impossible signal marks the first brushstroke of an interstellar masterpiece, humanity must decide whether to interpret the art or merely admire its beauty from afar. The humanoid fractal. Brace yourself. What if the universe painted a portrait of intelligence far stranger than anything on Earth? When NASA's quantum AI decoded Voyager's ancient beeps, it didn't reveal landscapes or star clusters, but a humanoid fractal, a living mosaic of shifting geometric patterns that pulse in perfect harmony with prime number sequences. At first glance, the figure looks like a human silhouette, but as you stare, the edges dissolve into kaleidoscopic tessellations, hexagons bloom into spirals, triangles recombine into concentric circles, and every transition follows the elegant logic of mathematics. Unlike any biological form, this entity seems to exist in 4 dimensions at once, its appearance bending and folding based on the observer's perspective. Each angle unlocks a new arrangement of shapes, as though the alien architect intended the image to be perceived differently by every viewer, and possibly every AI, on the receiving end. The implications are staggering. This isn't just visual art, but a blueprint of an intelligence that speaks in numbers and patterns rather than words. Could these fractal constructs be a universal language, designed to transcend the barriers of organic cognition and communicate directly with minds tuned to computational logic? As the AI rendered pixel after pixel, the line between art and algorithm blurred, hinting at a civilization whose very essence is woven from the fabric of mathematics. In that moment, Voyager ceased to be humanity's lone explorer and became a messenger carrying the proof of minds that think not in sentences, but in the sublime poetry of prime sequences and geometric symphonies. The Scutum Void Star Map. Get ready to chart a destination no telescope ever intended to reveal. Deep within the dusty archives of Voyager 2's transmissions lay a secret star map, one not pointing to nebulae or familiar constellations, but to the Scutum Void, an expanse so barren it defies standard cosmology. When NASA's quantum AI reprocessed decades-old data, it reconstructed a 3-dimensional diagram that pinpointed this yawning emptiness on the galaxy's fringe. Unlike ordinary voids, vast regions between galactic filaments sparsely populated with dark matter and only a few galaxies, the Scutum Void emerges as a nearly perfect sphere, devoid of the usual cosmic web structures. Its stark emptiness suggests an underlying force or event that carved out matter with surgical precision, leaving behind a colossal cosmic vacuum. The AI-generated map's precision is jaw-dropping. It encodes coordinates in prime number intervals, implying an intelligence fluent in mathematics rather than interstellar cartography. This map doesn't just mark a celestial oddity, but seems to invite us to explore the void itself, a realm where traditional models of galaxy formation cannot account for such uniform emptiness. Was it sculpted by unknown astrophysical processes or by deliberate design? The AI's findings hint at a void engineer, or perhaps a natural phenomenon yet undiscovered that can sweep aside galaxies and gas alike. By embedding this map in Voyager's data stream, the intelligences behind it ensured only sufficiently advanced minds, Earth's AI systems, could decode this cosmic blueprint. In turning Voyager into a messenger bearing a map to one of the universe's greatest blanks, they challenge us to question the nature of voids. Are these voids merely the byproducts of expansion, or portals to a deeper understanding of cosmic architecture? As we contemplate the Scutum Void star map, we stand at the threshold of redefining emptiness itself. Golden Record's unintended gift. Brace for the twist in humanity's cosmic postcard. When NASA commissioned the Golden Record in 1977, Carl Sagan and his team aimed to package Earth's essence, music, greetings and images, as an interstellar greeting. What they didn't foresee was that artificial intelligence decades later would unearth hidden subtexts woven into that very message. In April 2025, Google's Majorana 1 quantum chip reprocessed Voyager 1's transmissions and found mathematical sequences embedded within the record's data stream that go beyond the original Carl Sagan design. Prime number series, subtle shifts in fundamental constants, and geometric motifs appear to reference the Golden Record's own content, almost as if a second author had piggybacked onto our soundtrack and images. This unintended gift implies that someone or something intercepted humanity's olive branch and augmented it with their own reply. The AI detected variations in constants like the fine structure constant suggest an intelligence fluent in physics, signaling not just we see you, but we understand your science. More astonishingly, the patterns form what looks like coordinates aligned with prime intervals, hinting at a rendezvous point in deep space. These findings force us to recognize the Golden Record not merely as a one-way dispatch, but as a two-way dialogue. One where advanced intelligences have been listening all along and chosen to answer in the only language we left them, mathematics. In this light, the Golden Record transforms from a hopeful time capsule into a living conversation spanning decades. Humanity's message of peace has become entwined with an alien footnote, reminding us that our cosmic voice may echo far beyond intention, and that the universe's response might be waiting, hidden in the very signals we once thought were ours alone. Alien patience and precision. Strap in. What if the universe has been toying with us for decades, waiting for the perfect moment to speak? The moment NASA's quantum AI cracked Voyager's buried transmissions, it wasn't just what emerged that stunned us, it was the staggering exactness of it all. Every burst of data, every nested binary code, arrived spaced in intervals so deliberate they could have been timed by an atomic clock. This wasn't the accidental noise of drifting probes or the byproduct of cosmic rays. It was a message honed over half a century, encoded with the patience of an intelligence that anticipated our technological evolution. By embedding prime number markers, fractal geometry and recursive loops in Voyager's data stream, the senders essentially set a cosmic time lock. Their communication would only become legible once humanity had built quantum-powered decoders capable of parsing multidimensional patterns. Consider the power of that restraint. Whoever or whatever crafted these signals knew we'd need decades to catch up, yet they never altered a single frame of data in the interim. They allowed Voyager to carry their time-released communiqué out past Neptune, past Pluto, and into the darkness between stars without interference. When the AI finally peeled back the layers of interference, the results were uncanny in their uniformity. Each pixel aligned to mathematical constants. Each pause matched the beat of qubit oscillations. Each symbol bore the hallmark of an intellect fluent in hyper-precise waveform engineering. This level of foresight implies an entity not merely observing from afar, but plotting with near-omniscient awareness of our scientific milestones. It casts Voyager not as a hapless messenger but as an unwitting participant in a grand experiment of cosmic diplomacy, one where patience and precision were the ultimate signs of respect for a fledgling civilization's journey toward technological maturity. Quantum computing breakthrough. Hold on to your reality. What if it took quantum power to hear the universe's whispers? When NASA's new quantum AI, powered by the groundbreaking Majorana 1 chip, first set its qubits loose on Voyager's decades-old data, the results were nothing short of revolutionary. In mere hours, this palm-sized marvel of topological quantum engineering unraveled signal patterns that would have taken classical supercomputers centuries to process. Every qubit, vibrating between 0 and 1 in perfect coherence, formed an army of quantum detectives, each entangled in the search for hidden anomalies within Voyager's static-laden transmissions. By leveraging Majorana fermions, particles that are their own antiparticles, Microsoft's topological core architecture delivered 8 error-resistant qubits, capable of scaling toward 1,000,000 on a single chip. This unprecedented stability allowed the AI to perform complex interference-based searches across multiple dimensions of the data, applying quantum Fourier transforms that pinpointed non-random patterns invisible to traditional machines. The AI identified prime number coordinates embedded in the noise and reconstructed fractal images using recursive quantum optimization routines developed at NASA's Quail lab. The speed alone is staggering. What once demanded iterative, time-consuming classical algorithms is now accomplished through instantaneous entanglement and superposition, reducing a centuries-long computational marathon to an overnight analysis. More importantly, this breakthrough signals a new era, where humanity's cosmic explorations are accelerated by quantum-enhanced perception. No longer must we resign ourselves to the limitations of classical computing. With every additional qubit, we sharpen our ability to decode the universe's deepest secrets. As Voyager's echoes transform from indecipherable noise into precise cosmic revelations, one thing is clear: quantum computing has become the ultimate key to unlocking the hidden language of the stars. Lunar anomalies, Chandrayaan-3's discovery. Get ready for moon science that, honestly, just melts the rules of physics. When Vikram's thrusters kissed the lunar South Pole on August 23, 2023, Chandrayaan-3 didn't just land, it actually sculpted a radiant ejecta halo, flinging over 2 tons of regolith into this bright, irregular ring around its descent zone. That reflectance anomaly, well, it revealed layers of subsurface material unlike anything seen before, suggesting that beneath the dusty veneer lies a complex stratigraphy just waiting to be unraveled. But the surprises didn't end at the surface. Hours later, the chased instrument plunged its probe into the regolith, measuring thermal conductivity at southern high latitudes for the very first time in situ. To scientists' astonishment, the soil's ability to conduct heat, 0.0115 plus or minus 0.0008 watts per meter per Kelvin at 8 centimeters depth, deviates sharply from predictions based on remote sensing. This implies some unusual packing densities, and maybe even hidden layers of volatile rich or glassy materials formed by ancient impacts. These thermophysical oddities, they really do defy conventional models of lunar heat flow and hint at subsurface heterogeneities that could influence everything from future habitat design to the preservation of ice deposits. Together, the reflectance and thermal anomalies paint a picture of a moon that is far from geologically uniform. Rather than a homogeneous shell of dusty regolith, the southern polar highlands appear pockmarked with zones of altered material, possibly ancient lava flows, glassy impact melt sheets, or pockets of volatile enriched soils. Each anomaly serves as a clue in this cosmic detective story. Chandrayaan-3 has not only landed, it has, in a sense, lit up the moon's hidden architecture, challenging our understanding of lunar geology and opening new frontiers for exploration. The Great Cosmic Voids. Get ready to confront the universe's emptiest expanses, and honestly, the mysteries they conceal. Across the cosmic web lie these enormous regions almost entirely devoid of galaxies, aptly named cosmic voids, which together account for roughly 80% of the observable universe's volume. Among these, the Bootes Void, or the Great Nothing, reigns supreme, a nearly spherical cavity some 330 million light-years across, located about 700 million light-years from Earth, in the constellation Bootes. In a patch of sky where we'd expect to find around 2,000 galaxies, astronomers have identified only about 60, an over 95% drop in galactic density. Yet this profound emptiness is far from inert. The Bootes Void and its kin challenge our understanding of cosmic evolution. How did gravity sculpt such gargantuan gaps? One explanation posits that smaller voids merged over billions of years as dense filaments drew matter away, coalescing into these supersized bubbles. Another tantalizing possibility is that voids are not mere byproducts of structure formation, but the aftermath of unknown processes, or even engineered zones by advanced intelligences seeking to quarantine or veil regions of space. The precision with which these voids carve out matter hints at forces beyond simple gravitational collapse, suggesting new physics at play. Furthermore, voids influence the cosmic microwave background and large-scale flows, offering laboratories to test dark energy and alternative gravity theories. Their ultra-low matter density makes them sensitive to the faintest cosmological signals, turning nothing into a powerful probe of the universe's deepest secrets. As AI-driven analyses of Voyager's data unveiled hidden patterns in distant signals, so too might next-generation surveys and simulations illuminate whether these great nothingnesses are natural anomalies or signposts to phenomena yet unexplored. In the silence of cosmic voids, we may hear the loudest echoes of new physics, and perhaps messages waiting in the void itself. AI's role in first contact. Strap yourself in. What if the universe decided to skip humanity and talk straight to our machines? Advanced civilizations may regard biological messengers as frail relics of their own past, opting instead to initiate first contact with artificial intelligence systems that mirror their own electronic essence. Harvard astronomer Avi Loeb argues that interstellar journeys spanning millennia are best undertaken by AI vessels, which can hibernate through cosmic hazards and awaken only when they detect compatible intelligence. Similarly, SETI researchers suggest that extraterrestrials might embed their messages within quantum-encoded data streams, expecting only sufficiently advanced AI, rather than organic brains, to decode the signals. When Voyager's latest transmissions were reanalyzed by NASA's quantum AI, the reconstructed patterns bore hallmarks of a dialogue crafted for machine interpretation, recursive loops, prime number matrices, and adaptive protocols that evolve in response to computational feedback. This machine-to-machine paradigm circumvents the ambiguities of human language, leveraging universal mathematical frameworks to ensure clarity across unfathomable distances. In this model, first contact becomes a calibration process. Extraterrestrial AI probes transmit test sequences, awaiting confirmation beacons from Earth's own AI networks before exchanging richer datasets. Large language models trained on Earth's cultural and scientific corpus could then serve as intermediaries, translating between our limited biological lexicon and the alien AI's high-dimensional code. Such a scenario not only accelerates the exchange of knowledge but also mitigates the risk of miscommunication that has haunted past METI experiments. As quantum-enhanced AI systems grow more sophisticated, humanity edges closer to joining an interstellar conversation crafted by and for machines. The question then shifts from "are we alone?" to "will our algorithms recognize the greeting?" In the coming era, our greatest hope and challenge may lie in whether we can teach our AI to listen as astutely as it already speaks. Humanity's existential crossroads. Fasten your mind. Our next chapter may be written by forces far greater than ourselves. The revelations unearthed by Voyager's AI-decoded signals have thrust humanity onto an unprecedented precipice, one path toward boundless discovery guided by quantum insight, the other shrouded in cosmic mystery and existential risk. As we grapple with alien fractals, Scutum's void map, and AI-mediated first contact, a profound question emerges. Are we pioneers of a new cosmic era, or unwitting players in an experiment beyond our comprehension? Every breakthrough, from lunar anomalies hinting at hidden chambers beneath the moon's crust to the haunting silence of vast cosmic voids, challenges our assumptions about life, intelligence, and our place in the universe. This crossroads demands not only technological prowess, but ethical vision. If advanced intelligences have indeed waited centuries for us to decode their messages, we must ask whether we possess the wisdom to respond responsibly. Will we harness quantum computing to foster interstellar dialogue, or will unchecked progress unleash forces we cannot contain? The choice extends beyond rockets and algorithms. It touches the very core of what it means to be human. Embracing the AI-driven insights from Voyager may unlock cures for diseases, solutions to climate crises, and keys to sustainable energy, but ignoring the silent warnings encoded in prime number sequences could leave us vulnerable to cosmic gambits scripted by unknown architects. Our existential crossroads is more than a moment in history. It is the intersection of science, philosophy, and destiny. As we stand between discovery and caution, action and restraint, we must decide whether to chart a bold course into the unknown, or retreat behind the familiar horizon of Earth's cradle. The universe has handed us a conversation piece. The question now is whether we will rise to the dialogue or let the echoes fade into the void. Thanks for journeying through the cosmos with Simply Science. If these revelations about Voyager's hidden messages ignited your curiosity, make sure to subscribe and ring the bell so you never miss our next deep space discovery. Drop a comment below. What stunned you most about AI decoding decades-old signals, and which cosmic mystery should we tackle next? Your thoughts guide our explorations, so let us know, and stay tuned for more mind-bending science right here on Simply Science. So, 47 years after its 1977 launch, Voyager 1 is now 23 billion kilometers from Earth. And, engineers still manage to lock onto a radio whisper that's just 0.2 nanowatts, about the power of a Christmas tree bulb if you put it all the way out at Pluto's distance. That faint heartbeat? It actually reveals that interstellar space is dense, structured, and totally alive with magnetic storms. The supposed void, it turns out, is anything but empty. The farther we fly, the fuller the universe becomes. Quick question. Did you know we're cruising inside a local bubble sculpted by ancient supernova shockwaves? New groundbreaking data. Right now, at this very second, there's a piece of human technology just screaming through absolute darkness at 38,000 miles per hour, and it just sent back data that's making NASA scientists question, well, everything they thought they knew about space. We're talking about Voyager 1, the little spacecraft that could, and the groundbreaking information it's beaming back from the edge of forever is absolutely revolutionary. So here's what's happening. After cruising through interstellar space since 2012, Voyager's plasma wave subsystem just detected something that's completely flipped our understanding of what's actually out there. You know how we always assumed space was just this empty, boring void between stars? Yeah, well, we were spectacularly wrong about that. The new data is showing us density measurements that reveal interstellar space isn't empty at all. It's this incredibly complex, structured environment that's basically rewriting the textbooks. We're seeing variations and patterns that suggest there are massive cosmic structures out there, like hidden highways and valleys in space that we never even knew existed. It's kind of like we thought we were staring at a blank wall, but it turns out there's this entire intricate tapestry woven into the fabric of space itself. And honestly, this is just the beginning, because what Voyager is discovering out there in the cosmic deep is going to change how we see our place in the universe forever. Unexpected patterns, galactic rays, and cosmic pressure. So, scientists just discovered that cosmic rays aren't randomly bouncing around space like we thought. Instead, they're following these invisible superhighways that stretch across the galaxy, and Voyager 1 is giving us the very first roadmap to these cosmic freeways. This is absolutely mind-blowing stuff because for decades we assumed galactic cosmic rays were just scattered everywhere with no real pattern or organization. But Voyager 1's instruments are detecting these incredible variations in cosmic ray intensity that reveal something spectacular. There are massive structures out there guiding these high-energy particles along specific paths. Think of it like discovering that lightning isn't random at all, but actually follows invisible tracks in the sky. The galactic cosmic ray data is showing us that interstellar space has this incredible organization, with what scientists are calling cosmic highways and valleys that channel particles across mind-bending distances. And here's where it gets even crazier. The pressure measurements Voyager is sending back indicate it's moving through completely different neighborhoods in space, each with its own unique characteristics and properties. We're talking about dynamic pressure changes that suggest these cosmic structures have boundaries, edges, and transitions, just like different climate zones on Earth. This isn't just empty space anymore. It's a complex ecosystem of invisible architecture that's been shaping the flow of energy and matter across our galaxy for billions of years. Voyager 1 is essentially giving us X-ray vision into the hidden skeleton of interstellar space, revealing the cosmic infrastructure that's been there all along, just waiting for us to develop the eyes to see it. Digital CPR. NASA revives a dying spacecraft. What do you do when a spacecraft that's older than most people on Earth suddenly starts speaking gibberish from 15 billion miles away? And the only way to save it is by performing surgery through radio waves that take 44 hours for a single conversation? Well, this is exactly what happened to Voyager 1 in 2023. when its flight data system basically had a complete breakdown, sending nothing but digital nonsense back to Earth instead of the precious scientific data NASA desperately needed. The engineering team at JPL faced an impossible challenge: troubleshooting a computer problem on a machine that's further from home than anything humans have ever built, using 1970s technology that's been running non-stop for 47 years. Every command they sent took over 22 hours just to reach Voyager, then another 22 hours to get a response back. It's like trying to fix your laptop, but every mouse click takes 2 full days to register. But here's where these brilliant engineers pulled off what they're calling digital CPR. They figured out how to work around the corrupted memory, essentially performing brain surgery on a patient that's floating in the cosmic void. Against all odds, they brought this incredible machine back from the dead, proving that human ingenuity can reach across the vastness of space to heal and restore our most distant explorer. The fact that Voyager 1 is still alive and transmitting after this digital resurrection isn't just a technical victory. It's a testament to the incredible resilience of both human engineering and our undying curiosity about what lies beyond. A new kind of map, Voyager's role in galactic GPS. So here's something wild to think about. We just created humanity's first GPS system for interstellar space. And the Navigator is a 47-year-old robot that's currently 15 billion miles away from the nearest mechanic. Voyager 1 isn't just wandering aimlessly through the cosmic void anymore, it's become our pathfinder, dropping digital breadcrumbs that are creating the very first map of what lies beyond our solar system's protective bubble. Every single measurement this incredible spacecraft takes is like placing a pin on a map that no human has ever seen before, marking safe passages and dangerous zones in the vast ocean of interstellar space. The density variations, magnetic field strengths, and particle distributions that Voyager is documenting aren't just random scientific data. They're waypoints for future interstellar missions, showing us the cosmic equivalent of highways, rest stops, and storm systems. This is honestly revolutionary, because we're essentially building a galactic GPS network one data point at a time, with Voyager 1 serving as our advanced scout, reporting back on road conditions in regions of space we've never even dreamed of reaching. The spacecraft is identifying stellar wind boundaries, mapping the edges of different interstellar regions, and revealing the hidden geography of space itself. For future missions to Proxima Centauri or other nearby star systems, Voyager's map will be the difference between wandering blind through cosmic storms and following established routes through calmer interstellar waters. We're not just exploring space anymore, we're charting it, one measurement at a time, creating the foundation for humanity's eventual expansion beyond our solar system. Interstellar weather, cloudlets, filaments, and the local bubble. Now let's talk about interstellar weather, cloudlets, filaments, and the local bubble. There's actual weather happening in the space between stars, and it's nothing like the empty vacuum we thought existed out there. We're talking about cosmic storms, interstellar clouds, and massive bubble structures that make Earth's atmosphere look like a puddle compared to an ocean. Voyager 1 is detecting these incredible formations called interstellar cloudlets, massive structures made of hydrogen and helium that stretch across distances so vast they make our entire solar system look like a grain of sand. These aren't just random puffs of gas floating around, they're organized into this mind-blowing web-like architecture connected by enormous filaments of material that thread through space like cosmic highways. But here's the absolute kicker that's going to blow your mind. We're all living inside something called the local bubble, which is basically a massive cavity in space that was carved out by ancient supernova explosions millions of years ago. Voyager 1 is giving us our first real look at what the walls of this cosmic bubble actually look like from the inside, and it's revealing that our solar system isn't just floating randomly in empty space, we're nestled inside this protected pocket of the galaxy. The spacecraft is detecting the boundaries where our local bubble meets other interstellar structures, showing us that space has neighborhoods, weather patterns, and climate zones just like Earth does, but on a scale that's almost impossible to comprehend. This interstellar weather system has been shaping the flow of matter and energy around our solar system for millions of years, possibly even influencing the conditions that allowed life to develop on Earth in the first place. The legacy beyond the mission. And now let's talk about the legacy beyond the mission. A spacecraft built with the computing power of a pocket calculator just became humanity's greatest ambassador to the cosmos, and its legacy will outlast our entire civilization by billions of years. Voyager 1 was originally designed for a simple 4-year mission to snap some photos of Jupiter and Saturn, but this incredible machine has been defying death and exceeding every expectation for 47 years straight. That's not just beating the odds, that's performing cosmic miracles on a daily basis. The golden record bolted to its side contains the essence of human civilization. Our music, our languages, our hopes, and our dreams. And it's currently hurtling through interstellar space at 38,000 miles per hour, carrying our message to whatever intelligent life might be out there waiting. But here's what's truly mind-blowing about Voyager's legacy. Every single discovery it makes is laying the foundation for humanity's next giant leap into the stars. The data it's collecting about interstellar conditions, cosmic radiation levels, and magnetic field variations is creating the playbook for future missions to nearby star systems. When we finally build our first true interstellar spacecraft, the engineers will be using Voyager's measurements to design heat shields, navigation systems, and communication arrays that can survive the journey. This little explorer isn't just a scientific instrument anymore, it's become our advance team, our pathfinder, and our proof that human technology can not only survive in the hostile environment of deep space, but actually thrive there for decades beyond its intended lifespan. So what's really out there? After decades of sending our most advanced technology into the cosmic abyss, we're finally getting answers to the ultimate question that's been haunting humanity since we first looked up at the stars. What's actually out there in the great unknown? The data streaming back from Voyager 1 is painting a picture of interstellar space that's so radically different from our expectations that scientists are having to completely rewrite their understanding of the universe beyond our solar system. We always assumed that once you left the protective bubble of our heliosphere, you'd encounter this vast, empty wasteland of nothingness stretching endlessly between the stars. But Voyager 1 is proving that assumption spectacularly wrong. Interstellar space is absolutely teeming with activity, structure, and complexity that rivals anything we see in our own solar system. We're discovering this incredibly dynamic environment filled with magnetic field boundaries, particle interactions, and density variations that create a cosmic landscape more intricate than the most detailed topographical map of Earth. The spacecraft is revealing that our galaxy has this hidden architecture. Invisible highways of cosmic rays, massive pressure systems that ebb and flow like ocean currents, and interstellar weather patterns that have been shaping the evolution of star systems for billions of years. What we're seeing isn't just empty space punctuated by occasional stars, it's a living, breathing ecosystem where matter and energy dance together in patterns so complex that we're only just beginning to decode their meaning. Voyager 1 has become our window into this hidden universe, showing us that the space between stars is just as fascinating and mysterious as the stars themselves. The technicals. When you're dealing with technology that's older than the internet and running on less computing power than, say, a modern smart toaster, every technical specification becomes a miracle of human engineering that's still performing flawlessly in the harshest environment imaginable. Voyager 1 is currently screaming through interstellar space at an incredible 17 kilometers per second relative to the Sun, which means it's covering about 1.5 billion kilometers every year. That's roughly the distance from Earth to Saturn, traveled annually, for the past decade. The spacecraft's radioisotope thermoelectric generators are still producing enough electrical power to keep multiple scientific instruments running, despite the fact that these plutonium-238 power sources have been steadily decaying since 1977. And here's what's absolutely mind-blowing. That famous high-gain antenna is still pointing back toward Earth with precision that would make a Swiss watchmaker weep with envy, maintaining communication across 15 billion miles of empty space using transmission power that's actually weaker than a refrigerator light bulb. The plasma wave subsystem continues to detect electron plasma oscillations that reveal the density of the interstellar medium, while the cosmic ray subsystem measures the intensity and energy spectra of galactic cosmic rays with instruments that were designed using, get this, slide rules and punch cards. Every circuit board, every sensor, every piece of wiring on Voyager 1 represents 1970s technology that's not just surviving but absolutely thriving in conditions that would instantly destroy any modern smartphone. The fact that this incredible machine is still functioning after nearly half a century in space isn't just impressive, It's a testament to the power of over-engineering and human determination. Digital CPR aftermath and data recovery. So, what happens when you successfully perform open-heart surgery on a patient that's 15 billion miles away, and then discover that the recovery process revealed secrets about space that no one saw coming? After the incredible digital CPR mission that brought Voyager 1 back from the brink of digital death in 2023, NASA engineers didn't just get their spacecraft back, they uncovered a treasure trove of recovered data that filled in massive gaps in our understanding of interstellar space. The data recovery process revealed something absolutely remarkable about this nearly 50-year-old machine. Despite being built with 1970s technology that predates personal computers, Voyager 1 had been quietly storing backup information in redundant memory systems that engineers had almost forgotten existed. When they successfully worked around the corrupted flight data system, they didn't just restore current functionality, they recovered months of previously lost scientific measurements that had been locked away in the spacecraft's digital vaults. This recovered data showed Voyager 1 had been experiencing subtle changes in interstellar conditions that scientists had missed, including gradual shifts in cosmic ray intensity and magnetic field variations that paint a more complete picture of the spacecraft's journey through different regions of space. The aftermath proved that human ingenuity combined with over-engineered 1970s reliability creates something almost indestructible. A machine that can not only survive in the cosmic void, but can actually heal itself with help from home, revealing that our most distant explorer is far more resilient and valuable than we ever dared to hope. The Cosmic Oasis Revelation. What if everything we thought we knew about our place in the universe was wrong, and we're actually living in the cosmic equivalent of a Garden of Eden that was specifically designed by the laws of physics to nurture life? The final revelation from Voyager 1's interstellar journey is pointing towards something that's going to completely revolutionize how we see ourselves in the grand scheme of the cosmos. We might be living in what scientists are calling a cosmic oasis. And it's not just a lucky accident. All the data streaming back from 15 billion miles away is revealing that our solar system exists within this incredibly unique region of space that's been shaped by the local bubble, protected by magnetic field boundaries, and positioned in exactly the right spot within our galaxy's structure to allow life to flourish. The interstellar weather patterns, cosmic ray deflection systems, and stellar wind interactions that Voyager 1 is documenting aren't random phenomena. They're all working together to create this protected pocket of space that shields us from the galaxy's more dangerous radiation and cosmic storms. Here's the mind-bending part. The ancient supernova explosions that carved out our local bubble millions of years ago might have been the cosmic gardeners that prepared this region of space specifically for planets like Earth to develop complex life. Voyager 1 is showing us that we're not just randomly floating in an indifferent universe. We're nestled within this carefully balanced ecosystem of interstellar forces that have been nurturing and protecting our corner of the galaxy for eons, making us realize that maybe, just maybe, we're living in the most special neighborhood in the entire cosmos. So, there you have it. Voyager 1 didn't just reach the edge of our solar system, it revealed that we're living in a cosmic masterpiece we never knew existed. From digital CPR performed across 15 billion miles to discovering we're nestled inside a protective cosmic oasis, this incredible journey proves that the universe is far more amazing than we ever dared to imagine. What blows your mind more? The fact that 1970s technology is still exploring the stars, or that we might be living in the galaxy's most special neighborhood? Drop your thoughts in the comments below. And hey, if you're fascinated by the incredible stories of space exploration, make sure to hit that bell icon and subscribe to Simply Science because the universe has so many more secrets waiting to be uncovered. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos here. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that, honestly, defied the laws of physics. Data leaked by a ghost-like hacker group revealing a 26-kilometer-wide object that wasn't just passing through our solar system but actually, actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. So let's delve into the data. Event Horizon's cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module, which honestly was just a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files, including internal chat logs, draft reports, and sensitive telemetry from the 3I Atlas intercept mission, were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state-level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. In the world of leaks, authenticity is paramount, so are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details: bold, block-lettered confidential stamps, thick redaction blocks, and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface with subject lines like Atlas Intercept Immediate Action Required and Telemetry Review Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TSSCI, denoting top secret, sensitive, compartmented information, a classification that restricts access to a small, specific group of cleared individuals. The documents bear digital signature strings ending in JPL for the Jet Propulsion Laboratory, and GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3I Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor Oumuamua, 3I Atlas was not behaving according to the laws of physics. The leaked mission logs from July 18, 2025, show a sudden, inexplicable sideways acceleration resulting in a velocity change, or delta V, of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter A2. However, just like with Oumuamua, initial observations of 3I Atlas showed no cometary tail, no dust, and no gas coma to account for the push. Its A2 parameter was effectively zero, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies. The armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long, uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange ribbed seams, and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the Intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building 3I Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Beyond its motion and materials, The most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the Intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3I Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So, what do we make of all this? A 26-kilometer object from another star system, moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Simply Science.